Hey guys, welcome back to Mr. Estabrook's channel. It is Izzy Sham, and today we're going over lesson 6.3. So make sure to like, comment, and subscribe. This is hashtag not spawns, but you know, that's all. Oh my god, this is a bad one. Shoot.
What we're doing in this problem is finding the general solution of this differential equation, and it's in terms of dy dx, and we always want the d whatever to be up in the numerator, so we're going to move all the y stuff to the left, all the x stuff to the right, so that dx will be in the numerator on the right, dy is already in the numerator on the left. In other words, let's see, we're going to keep dy over there, we're going to move dx to the right, multiply both sides by dx to get it over there. We have to divide both sides by y to get it out of the denominator. And the x was already over here. We're dividing by x squared plus 4. So it's just moving things around. So only y is on the left, only x is on the right. And now that we have that, we can actually integrate. We're going to integrate both sides. The integral of dy over y, that would be the natural log of the absolute value of y. On the right side, the integral takes a little bit more work. It's almost an arc trig function, but it's not. Instead, we could do a u substitution. Let u be equal to x squared plus 4, because it's in the denominator. Du then would be equal to 2x dx. In other words, in order to integrate this one with u substitution, we would have to multiply that by 2, so now it's 2x dx. Simultaneously multiply out front by 1/2. So I'm doing a u substitution without writing all of that down. So now when we integrate this, it is 1/2 the natural log of x squared plus 4 plus some constant. And as far as the x squared plus 4 goes, that has to be positive. X squared is at the minimum 0, but something else positive more likely. Plus 4, it stays positive. So really these absolute value bars could just be parentheses. And then from this green equation, we're trying to get this solved for y. So I could take e to the power of both sides, or I could realize also that this 1/2 that is in front of the ln, I could put that in the exponent for the x squared plus 4. So we could say the ln of y is equal to the ln of x squared plus 4, all of that to the 1/2, which really means the square root of that. It's an optional step. I think it's a good step to do at this point. We could do it later as well, but I think it's a little simpler to have it right then. And now, to get rid of the ln from both sides, we can take e to the power. So we have e to the ln of y, which makes it just become y on the left. And on the right, I am going to write everything. It's e to the ln square root of x squared plus 4 plus c. Now note on the absolute value bar there, because of that, we're going to at least temporarily put a plus minus here to accommodate for that. And then this right side, we can simplify it quite a bit. E to the ln of the square root of x squared plus 4. Well, e and ln are inverse operations of each other, so those are really going to cancel each other out. Then there is this plus c in the exponent. So as far as that goes, if we had something like e to the x plus y, that's the same thing as e to the x times e to the y. We can split it up like that. So as I'm seeing this problem that we have down here, just using properties of logs and so forth, we could say that y equals plus or minus square root of x squared plus 4, that's the e to the ln of square root of x squared plus 4, times e to the c. So the e to the c is still in there, but e to the c is really just another constant. I'm just going to wrap that constant into just a number. If you had it as e to the c, that would be okay, but again, it's a number, so why not call it that way? So here is our general solution. Now that we have this general solution, we're going to look for a particular solution when y equals 2 and when x equals 3. We're going to plug them in. First off, plug 2 in for y. So 2 equals the square root of negative 3 squared plus 4 times some constant. And 2 is a positive number, so I'm not going to worry about the plus or minus. I know that this is going to come out positive. The goal here is to solve for c. Underneath the square root sign, negative 3 squared plus 4, that's 13. To get c all by itself, we could divide both sides by the square root of 13. So there is our c value. Now bringing that together with what we already had, we can say that our specific equation, our particular solution, is y equals 2 over the square root of 13 times the square root of x squared plus 4.